So this is the physics section then of the Unit 1 Applied Science, and this is like the revision that you could be doing to get yourselves a really good grade. So the first kind of things they're asking you is this sheet here. It's types of energy, energy transfer, Sankey diagrams, things like that. I'd like you to pause this page, have a go, and then in a minute I'll come back with the answers. So first thing you need to know is the types of energy. You might have heard the rhyme, English kids hate learning GCSEs, okay? And they're the types of energy you need to know. What energy occurs in a TV? Electrical energy be converted to light, sound and heat, with light being useful, sound being useful and heat being wasted. What type of energy occurs in a car? So chemical is the energy in, that's the energy in as well. Chemical energy in, and then kinetic and heat. So kinetic being the useful energy and heat being wasted energy. This equation then, nice easy equation, but potentially will be given to you anyway. Efficiency equals useful energy out, total energy in. Okay, this question's got loads of information here. If you read, it says for every 1,000 joules, that's the energy in, okay, 400 is used to generate electricity. 600 of it is wasted. So you would do total energy in on the bottom over the useful 400 and times it by 100 would give you 40%. Okay, Sankey diagrams, can you label an input? So this is the input energy here, in. This is the useful energy here, and this is wasted. Okay, can you see how all the squares, they add up? So there's 20 squares there, 15, 5, so it's drawn correctly. Efficiency again, 10 joules go in, so that's going to be on the bottom, 7.5 is useful. Okay, make sure you times by 100 when you're doing percentages. Sustainability then. Sustainability is using energy sources in such a way that we do not put the risk of the future to meet future people's needs. Okay. Carbon footprint is the measure of activities which release greenhouse gases, so stuff that releases CO2, so stuff like cars, buses, generating electricity, things like that. Increasing the levels of carbon in the atmosphere contributes to greenhouse effect. The emission of sulfur dioxide is what causes acid rain. Next kind of one then, looking at energy sources, the advantages and disadvantages of renewable and non-renewable types of energy, and a little bit on the national grid. Again, pause it, and then I'll come back with the answers. Okay, so advantages of fossil fuels, they give a large amount of energy for a small amount of fuel. The fuels are readily available. If you need more energy, you can just burn the fuel. They are relatively cheap. Disadvantages, it's not a long-term goal, it's not sustainable, they can cause pollution. When burnt, they release CO2, which goes to greenhouse emissions. Burning fossil fuel produces carbon dioxide, which contributes to our greenhouse gases. Okay, going down the bottom then, looking at the national grid. What is the national grid? It's a series of wires and pylons which connect power stations to electricity in home. What's the step-up transformer? Step-up transformer steps up the voltage to limits heat loss, so it travels a lot faster along these wires. Step down then steps down the voltage so that we work safely. Then there's quite a lot of information here about all the different types of renewable and non-renewable energies, okay? I'm not going to read through it all, okay? I just want to point out a couple of things that might be quite good to use, okay? Lots of these do not produce air pollution, so that's a good advantage of them, okay? Potential infinite resource, so it means we can use it over and over again, okay? Big disadvantages tend to be costly, and like costly to build, eyesores, stuff like that, okay? Then at the bottom, there was just a little bit of a definition about renewable energy. So renewable energy is defined as the energy source that is likely to run out. So moving on then, this is looking at different types of energy transfers. The bit at the top is focusing on convection, conduction and radiation. Then we're looking at how energy is lost in the home, and then how we pay back energy lost in the home, and a little bit on vehicles. Okay, so again, pause and have a go at the questions. So heat energy will travel from an area that is hot to an area that is cold through a process known as conduction. That is in solids. When it is in liquids, it's called convection, and when it's in gases, it's also called convection. Heat transfer through a vacuum occurs by the process of radiation. A solid that does not really transfer heat is called a good insulator. Where is energy lost in a home? Roof, windows, walls and doors. Heat energy is lost through conduction, through the walls and the floor, because that would be solid. Convection is when cold air enters the home through the gaps in the windows and the doors, and then radiation through walls, windows and doors. Radiation, remember, occurs in a vacuum, which means there are no particles. How can we limit heat loss in the home? We can insulate the roof and walls, double glazing the windows and draft excluders by the doors. Payback time then. So it says here, there's the equation, you have to know that one. It costs $2,400 to fit the double glazing. Each year you save £200. What is the payback time? So it's the total cost of insulating, which would be $2,400, divided by the cost you save each year. So it would take you 12 years to pay it back. Okay. Efficiency, electric cars are the most efficient in terms of energy efficiency, then petrol, then diesel. Okay, this bit by here is on your sheet and you kind of need to read it and understand it. So how can you limit energy loss in a vehicle? You could idling losses, so making sure you've got ecosystems in the car or start stop. Accessories such as air conditioning, power steering, and all energy generated from the engine, so make sure you don't use them. Making sure your car is aerodynamic, things like that is how you limit energy loss. Finally then, circuits is the last little bit that you need to know about. Okay, so there is some fill in the blanks and some little bits of information to fill in. Again, have a go yourself and then in a minute the answers will appear. So these were the one, you have to know them all, but I didn't take all of them away. I just put a couple in. So that's the switch, diode, variable resistor and a bulb, voltmeter and ammeter. You have to know them all. Okay, but they're just the ones that I kept up. Okay, draw a simple circuit for investigating current and voltage with a diode. What is the method? So here's a simple circuit, okay, or standard test circuit. So a standard test circuit is another word they might use, okay? So remember your voltmeter always comes off. That's the symbol for diode, variable resistor, battery, and an ammeter, okay? First thing you do, set the VR to max. Use a voltmeter to measure voltage, an ammeter to measure current. Adjust the resistance incrementally, flip the battery and repeat. And then flip the battery and repeat, okay? The next little bit then, okay, is looking at the layout. So a series circuit looks like this, okay, so all the current flows in one direction. Parallel then is when it splits, okay. So current in a series circuit stays the same, whereas the voltage is shared, okay, so the voltage would split. I guess split is a better word to use than shares. Split. Current then is split in a parallel circuit, and the voltage stays the same. Wire circuits, okay, that's a safety aspect, okay, to make sure that if one blows, they don't all blow. The other thing is the bulbs are brighter. And then you have to know the three types of graphs and be able to sketch them. So this is a filament, remember it looks like an F, fixed resistor and a diode. Okay, so current always goes out, voltage always across, and you have to be able to draw all three and label them.